Open your book to page 352. Today's lesson is to find the area of the triangles. I'm pretty sure you know when you have a triangle, you have the height and you have the base. So in this case, the area equal to 1/2 base times height. So you should know this already from probably learned it from like 4th grade or 5th grade. Okay? So this is when you have one side. So when the problem they give you one side and the height, your formula is 1/2 base times height. Now when they give you two sides, if they give you A and a B and they give you the angle right over here, so this is when they give you two sides. Then the formula for the area of the triangle is A equal to 1/2 AB sine theta. Okay. And the reason for that is, if you think about it, right, this is the height. So if you use your trigonometric ratio, so H over A is equal to sine theta. And if you switch over, so H equal to A sine theta. So you see that A sine theta is actually the height. So it's same as this one here. So A sine theta is your height. So this is basically 1/2 base times the height. Again, A sine theta, this is the height, right, from your trigonometry. Now you have to make sure that the angle is between the two sides. So if the angle is not included in the two sides, you have to use a law of sine or whatever method. You got to get this angle in between. So again, one side is giving, use 1/2 base times height. Two sides are giving, basically, if you want to do it by two steps, that's fine. You can use the sine function to find the height, and then after that it becomes 1/2 base times height. So the same thing. Okay. Now when the three sides are giving, so you have the A, B, and the C. This is actually came from a special case. The area for three sides giving is A equal to square root of, this is called a hero's formula. This is on page 353. And the formula is S, I'm going to write it differently so easier to remember. So it's S minus A, S minus B, S minus C, and times S. Okay. So S is called a semi-perimeter. So S equal to half of the perimeter. So it's A plus B plus C over 2. Okay. Now this is come from a special case. What happened was, this is talking about when you have a circle and you have a quadrilateral, any kind of four-sided polygon in a circle. Let's say you have a circle and you have a polygon, a quadrilateral inscribed in there, right? And you have four sides. So you got A, B, C, D. The formula for the area of this quadrilateral is area equal to square root of S minus A, S minus B, S minus C, S minus D. So what happens is when D becomes 0, so think about what happens when D equal to 0. When D equal to 0, you only got three sides. So that's why. So if you think about D equal to 0, it becomes this. So that's why the D equal to 0. So you got S. That's what that is. Okay. So this is a special case of that. The triangle is a special case of the quadrilateral. That's why you don't have minus D over here, because D equal to 0. Right? Again, when D equal to 0, you get a triangle. Okay. So this is the formula that you need to use. So again, one side is 1/2 base times height. Two sides is 1/2 AB sine theta. And when you have three sides giving, you use hero's formula. And so it's S minus A, S minus B, S minus C, and S minus D. But because triangle, the D equal to 0, that's why you don't see anything. And then S is the half of the perimeter. So to find half of the perimeter, you add A plus B plus C, and you divide by 2, right? So over here, if you have a quadrilateral inside a circle, then you do the same thing. So S will equal to A plus B plus C plus D over 2. Right? Again, half of the perimeter. You add all four sides, divide by 2. Okay, now let's go over some examples of how to use these. Let's go to example 1. You have this triangle, 8.00 meter, 35 degrees, and 5.00 meters. So this one had two sides and the angle in between. So this is the second situation. So area equal to 1/2 AB sine theta. So area equal to 1/2, and it doesn't matter which is A, which is B, as long as that angle is in between. So you got 8 times 5 sine of 35 degrees. Enter in your calculator, work it out, you get 11.5 meters squared, and that's it. And notice over here, there are 3 significant digits, right? There are 3 significant digits, so your answer should be 3 significant digits, 3 digits. Okay? And that's it for example 1. Now let's go to example 2. Example 2, it says find the area of a triangle with a side A equal to 12, B equal to 8, C equal to 6. And again, if you don't know exactly what it looks like, it doesn't matter. Just draw a triangle. Okay? So this is 12, 8, and 6. So this is all 3 sides given. So first, let's look for S. So S is half of the perimeter. So it's 12 plus 8 plus 6 divided by 2. So S equal to 13. Right? Now let's just call this A, call this B. Doesn't matter which is which. So area equal to square root of S minus A, S minus B, S minus C, and S minus D, which is 0. So that's why you got S, right? And for me, it's easier to remember this. Read the one in the book. They put an S first. Okay? So I kind of don't like that. So you got 13 minus 12, 13 minus 8, 13 minus 6, and 13 minus 0, right? So area equal to 1, 5, 7, 13. Use your calculator, punching all the numbers. So A equal to 21 centimeters squared. Okay, and that's it. So again, it's very simple. Now let's go to example 3. Example 3 says find the area of a triangle with alpha equal to 39, small a equal to 9.4, and b equal to 7.2. And so let's go and call this A, B, C. So this is small a, small b, small c. So alpha is 39. Small a is 9.4. And b equal to 7.2. Okay, so this is the 2 sides giving situation. But the problem is you need to get an angle between here. You need to get the angle C. So, and you don't have. So what you need to do is you have to use the law of sine. So you need to get C. So you want to do sine C. Well, you cannot do this. You don't know the C, so you cannot do that. So you have to kind of do it in the other way. Because what happens is, that's why I want you guys to write these things down. It helps you to think. So write down A, B, C, A, B, C. So that way you can know what you have and what you need to use. So from here you can see that you have to get angle B first, right? So let's go and do sine B over B equal to sine A over A, and move the B over here. So sine B equal to 7.2 times sine of 39 degrees over small a is 9.4. So get your calculator. So sine B is equal to 0.4820. So angle B equal to 29 degrees. So this is 29 degrees. Now remember, whenever you use the law of sine to get an angle, you have to think about the second angle, right? But in this case, you don't have to worry about the other one because the other one would be 151. So B2 will equal to 151 degrees. But cannot. Remember what I said, right? Only the biggest angle can have over 90 degrees. Okay? And so this one, you know that it's not the biggest angle because it's not facing the longest length. So that's why you want to get a smaller angle first. So that means you cannot have that. Okay? Again, because this is not the biggest angle is facing the longest length. So this one is not even, the longest. Therefore, it cannot have anything over 90 degrees. That's how you know that you can eliminate that. So now you use 180 minus 39 minus 29, and you can get 112. So now, once you find the angle is 112, you don't have to worry about the length C. You don't need that. So now you can use area equal to 1/2. Now to be flexible with your variable, I know it's AB sine theta, right? But AB is just two sides. It can be AC, depends on what the two sides are. Okay, it depends on what angle. As long as it's the two sides with the angle in between. So in this case, yeah, it's AB sine actually C, right? Again, two sides with the angle in between. Okay, so now you can go and substitute. So area equal to 1/2. A is 9.4. B is 7.2. And sine of C is 112. Punching all the numbers, and you get 31 feet square. Okay, and that's it. Okay. Okay, so let's go and do some practice.